Let us see what and all we will learn in this lesson. So, first of all, we will try to define the right perspective in order to make use of tools like Python in the right way. See, in data science, there are a number of tools which are used. Okay? And at the same time, Python can be used for a number of reasons and in a number of ways and in a number of areas. But we need to restrict ourselves to make maximum use of Python in data science. So let us see what and all we'll learn so that we set the right perspective of using Python in the upcoming chapters. We'll try to define what is data science. We'll try to see what is the need of data science. We'll see some use cases and applications of data science and skills required for a data scientist, and what is the role and responsibilities and day in and day out activities of a data scientist, and also look at the life cycle of data science. So what is data science? Data science is a blend of various tools, algorithms, and machine learning principles with the goal to discover hidden patterns from the raw data. So data science is a blend of various tools. Python is one of the tools. There are more tools which we will discuss later, which will be used in data science in order to draw conclusions. And what does it do? The goal is to discover hidden patterns from the raw data. When we say raw data does not give any sort of a meaningful information. So the data science is also used in areas wherein we cleanse the raw data to draw meaningful information before we arrive at or proceed to arrive at any sort of a conclusion. And data science is primarily used to make decisions and predictions. These are the two main important goals of data science. If we are dealing with data, and from that, if we are trying to extract some meaningful information, ultimately we need the goal we are trying to define is to make decisions and predictions. Let us see what is the need for data science. Now, in today's world, data comes in from various sources. For example, when you log into Facebook, you see data in the form of text coming from somewhere, you see streaming data coming from somewhere, you see some images. So there are multiple sources from where data flows in. At the same time, you have different variety of data. You have a type of text, you have type of numericals, you have binary data in the form of streaming videos, images. All these are unstructured data. And when it comes to data storage, traditionally when data used to be stored in database management systems called servers, which used to be upgraded on a vertical basis. For example, if you need 100 GB more, it would be added to the server in a vertical fashion. Nowadays, storage is actually upgraded in a horizontal fashion. So all this amounts to big data coming from various sources, and it also includes a lot of unstructured data based on which we need to make decisions. And for this, there is always a lack of predictive analytics, which was there, and there was a lack of scientific insights because these were not giving meaningful information. So, in order to derive a meaningful information from all this unstructured data, what we now call as big data, we need data science for making decisions and predictions, and it will also aid in pattern discovery. So, what do you do with the data in data science? Let us look at some of the areas where we can apply data science to. We can recommend the right product to the right customer to enhance business. Now, how do we do it? We we can actually study a customer behavior, his buying patterns, just like any of these e-commerce sites like Amazon and Flipkart do. They come up with customized advertisements for certain customers and recommend the product of their interest. So all this includes a lot of data science. Predict the characteristics of high LTV customers and helps in customer segmentation. This could be applicable to, say, an investment firm or a mutual fund customer, wherein it tries to segregate a normal customer from a high level customer based on his investment and investment patterns. Build intelligence and ability in machines. We are already aware about some of the machines, even our refrigerators which we use are AI enabled. Based on certain temperatures, they start behaving in a different way at a certain time or a period of time. Some other areas could also include, say, washing machines, and then the vacuum cleaners, uh, which actually takes a lot of data by reading the environment and then performs based on certain parameters, etc., etc. In the banking sector, you can predict fraudulent transactions beforehand. This could involve various factors like reading the customer spending patterns, the areas where he spends, the location from where he normally spends, and etc. etc. In the electoral sector, perform sentiment analysis to predict the outcome of elections. So, in beforehand itself, people have a fair idea based on regions on who will win the elections in their particular region. So, this could be due to a lot of factors. One of the factor could be doing a sentiment analysis of people and looking at where or which party they are inclined to. Here are some use cases of data science. We will look at this sector wise. First, let's see the marketing sector. Data science is used in predicting lifetime value of a customer. It can be used for cross selling, it is used for upselling. In the travel sector, it is used for dynamic pricing. This comes into picture where there is a lot of demand or less demand for, say, uh, hotels or flights. So primarily it is used in the ticketing sector. And then predicting a flight delay. In the healthcare, it can be used for predicting a disease. It can be used for effectiveness of a drug or a medicine. In the sales sector, it can be used for demand forecasting of a particular item. It can be used for discount offering, maybe on a particular, say, season, or for any of the other reasons. In the credit and insurance and other banking sectors, it can be used for fraud and risk detection, claims prediction. The automation sector, it can be used for self-driving cars, wherein there are no drivers for the cars, pilotless aircrafts, drones. Drones are used to deliver items from the source to destination. It has already started in certain areas. The social media, it can be used for sentiment analysis, digital marketing, etc. etc. Let us look at the skills required to be a data scientist. The primary skill which is required is a domain expertise. Even though this can be acquired while you are in the field, but if you have a prior knowledge of the domain, it is always a big bonus. Mathematics is highly used in data science, especially the statistical part of mathematics, descriptive statistics, inferential statistics, probability. All these things are used for drawing a conclusion and trying to analyze the past data. A computer science knowledge, though not a deep programming knowledge, but an ability to pick up a 4GL programming language like Python is always a plus. A little bit of data processing is always a plus too. So when you call someone as a data scientist, it could always be that he is strong in one of these aspects, two of these aspects, or maybe all the three. Now, a person who is an expert in all the three could be one of the best data scientists available. So what does a data scientist do? He predicts future based on past patterns, making use of AI and machine learning. Now, one is he has to predict the future. At the same time, he also needs to gather and analyze the past and historical data. Data scientists could be at various levels. One at the level wherein they are placed in to do business intelligence, which is more related to procuring and presentation of the historical data and analysis involved in that historical data. The other layer of a data scientist could be that he takes this data as an input and this analysis given as an input, and he builds algorithms to predict the behavior in the future. There could be different layers based on your organizational structures. A data scientist also examines data from multiple sources. Now, it is not only from a single database. A data scientist is also expected to analyze data coming from other sources in terms of, say, streaming media or blob images, etc., etc. If he has an idea of, say, big data and data transformation and extraction, it is an added advantage. A data scientist is also expected to find correlations and hidden patterns from data. So there could be some areas wherein the information is related, but you cannot arrive at a firm conclusion. So you're expected as a data scientist to find the correlations or maybe the probable relations and hidden patterns so that this can be used in future. Life cycle of data science mainly come under these 6 steps. So there is an identification of a use case or a discovery that this is where, this is what I need to do. And you start preparing data and collecting data for that particular use case. Then using the data, one starts planning a model to be built. And once the model is built, then you need to operationalize and then communicate results to the stakeholders. So we will look at this with an example. So here is a life example wherein a doctor talks to a data scientist. So the doctor has a question: what if we could predict the occurrence of diabetes and take appropriate measures beforehand to prevent it? A data scientist comes up with an answer saying, definitely, sir, let me take you through the steps to predict the vulnerable patients. So, as we looked at the life cycle of data science, let us look at the first step, data discovery. Discovery involves acquiring data from all the identified internal and external sources that can help answer the business question. The business question in our case was to predict the occurrence of diabetes. Now, this data could be logs from web servers, social media data, census data sets, data streamed from online sources via APIs. The doctor gets this data from the medical history of the patient. So, based on the medical history of the patient, he comes to know that number of times he has been pregnant, plasma glucose concentration, VP. So these are certain attributes which would aid in identifying that a particular person is diabetic or not. He has certain fields like age and income also, which may or may not be related to the diagnosis procedure. Now, this data which we see on the right hand side, this is what he receives. This could be absolutely unstructured data. These are some comma separated values with certain digits, numbers, characters, blanks, everything in it. So this data can have a lot of inconsistencies like missing values, blank columns, abrupt values, and incorrect data format which need to be cleaned. So here is where this data preparation comes into picture. It is required to explore pre-process and condition data prior to modeling. This will help you to spot the outliers and establish a relationship between the variables. When we say outliers, outliers could be something which is, which lies totally out of the context. For example, a person aged 995 years. Now, this is some inconsistent data which has come in due to some reason. A person cannot be 995 years old, or a person cannot be 0 years old. So, these are some of the inconsistencies which we need to take care before we, we cleanse the data. So, this data has a lot of anomalies and needs cleansing before further analysis can be done. So, let us look at this red marked areas wherein number of pregnant, instead of a digit, it has a character as 1. For glucose levels, there is a blank. For BP, it shows 6600. These are some of the anomalies. BMI also contains a blank cell. Income is not at all related to the diagnosis. So what we do is we clean and pre-process this data by removing the outliers, filling up the null values and normalizing the data type. For example, number of times pregnant, we have put a 1. For glucose levels, we have put 97. There are methods to normalize it. We will discuss it. There are some statistical methods which are used, like mean, median, mode, which we'll be discussing later. Probably we would also discuss it when we are going to do artificial intelligence and other techniques. BP has been normalized to 80. The BMI has a numeric value of 39. And we have also removed income, which is not related to the diagnosis. The next step in data analytics is model planning. Here, we determine the methods and techniques to draw the relationships between variables and then apply exploratory data analytics using various statistical formulas and visualization tools. So visualization techniques like histograms, line graphs, box plots, etc. to get a fair idea of the distribution of data. We also develop data sets for training and testing purposes. So a big population of data, from a big population of data, we might take a sample for testing purposes and try to apply that sample to the population. So we might have two data sets wherein we want to test it on a smaller data set and then we would like to apply it to the bigger data set. And consider whether existing tools will suffice for running the models. And analyze various learning techniques like classification, association, and clustering to build the model. So here is an example wherein we build a decision tree based on different attributes. First, we take up glucose and let us take this path. If it is less than 127 and the person is pregnant less than 5 times and the age is less than or equal to 28 and the BMI is this much, then the diagnosis is negative. Same way, if glucose is greater than 127 and also greater than 154, then it is positive. So this is a decision tree which will aid us to diagnose diabetes. The next step in data science is operationalize, wherein we deliver the final reports, briefings, code, and technical documents to the stakeholder, and then implement a pilot project in a real-time production environment. Now, we were doing this in a training or a testing data set. Now we will try to implement it in a real-time production environment, and then try to look for performance constraints, and again try to understand on how it performs in the real-time environment. Now, this is going to be an iterative process wherein we keep on refining things until we get an optimum result. And then we communicate the results, identify all the key findings, and communicate to the stakeholders. The stakeholders could be doctors here or some other head. Then explain the model and result to the medical authorities. We also need to explain them on how we built the model, and what are the parameters we built the model, what kind of inputs we worked on, and all those things. And then determine if the results of the project are success or a failure based on the criteria developed. So an example of results could be diabetes positive set. Glucose is greater than 154, glucose is greater than 127 and less than or equal to 154, and BMI is greater than 30.9, glucose is less than 127 plus pregnant for more than 5 times. We say a person is not diabetic if glucose is greater than 154, glucose is greater than 127 and less than 154, and BMI is less than 30.9. So based on the decision tree which we used, we can know whether the patient is vulnerable to diabetes or not. So in the following chapters, we will be making use of a lot of tools for doing analysis and prediction. And we will be using those tools in each of these steps of data science. Thank you.